Hey everyone, this is Joseph from dataengineering.com. In this video, we are going to be looking at how to pull data from an API using serverless functions, specifically AWS Lambda, and we will store the data in a cloud storage system. In this project, we will be using AWS S3 for this purpose. As always, if you'd like to follow this along in the blog format, I'll leave the link in the description below. So let's get started. So first, let's define what serverless means. It does not mean that there are no servers. All it means is that you don't have to handle server maintenance, security patching, and things like that. All you will have to do is write the code and deploy it to a serverless function, and the cloud service provider will take care of the execution and maintaining your server, security patching your server, things like that. You should also define a trigger for your code to run. For example, it can be an API call, it can be some data getting uploaded to a cloud storage system such as S3 or other such triggers. And user will also not be able to log into the running server. Because this is serverless, you do not have access to the server in case something goes wrong and you want to SSH into it and debug the issue. So let's look at a simple example of pulling data from an API and writing it to cloud storage. So all we are going to do is pull data from an API, save it to a local file or local folder in our case, and then upload contents of that folder to a cloud storage provider such as AWS S3. And we are going to write the code locally, deploy it to AWS Lambda, and set a trigger which specifies that the Lambda function be executed every 5 minutes. And this is what it looks like. The Lambda function starts every 5 minutes. The first step would be to pull data from an API into multiple local files. The second step would be to upload those files to S3, and then it stops. And this process will run every 5 minutes. Some general best practices for pulling data from an API. So the first one is pagination. The idea is to pull data in chunks instead of all at once. So what does this mean? If you think of any UI, you can see that only part of the page loads, or you have an option to press next to get the next chunk of data. So you can think of pagination similar to that. So you get data in chunks instead of pulling all data at once, because the data can be too large, and also this enables your server to handle the amount of data in memory with one single data pull. The second one is retries. Most APIs are stable, but sometimes your API call may fail due to your API server being temporarily down, some network issues, or other unforeseen issues. In such cases, it's generally good practice to have a few retries, and the number of retries depends on the stability of your API and general best practice for that API. But generally, it's 1 or 2. The last point is disk persistence versus in-memory. So when you're pulling data from an API, you could either store that data to a local file, which we specify as disk persistence, or keep it in process in memory. Keeping data in memory would be much faster because you're not writing it to a file and then reading it back in, but it also requires that your process has enough memory to handle the amount of data that you're pulling from the API. So let's look at the code and see how to execute this and deploy this to AWS Lambda. All right, let's look at some code. So as always, I'll leave the link to the blog in the description below. The code is there as well if you'd like to follow along there. But let's get started. So first, let's make a directory called data pool. And let's create a file called, let's call it Lambda Function. It's a Python script. So when you're creating a Lambda function, the entry point to the code execution, or the starting point of your code execution, is going to be a function called Lambda Handler in Python. So let's call it Lambda Handler. It needs to have these two input parameters. So what are we going to do? So we are going to first get the number of records that we have to download. So let's assume we have this function which we will fill in later. So once you get the number of records, then we are going to actually go ahead and download those number of records, and then we are going to save the content to S3. So when we are saving to S3, we need to have different folders for each save. So let's say you run this Lambda function at 12:10, you want to save it to one location, and the next run, let's say at 12:15, you want to save it to another location. So we will see how we namespace our S3 locations in this getKey function. So once you have the key, you want to get the files that you would have downloaded in this download data function. So basically this list comprehension will get all the files in a local directory and make it into a list. Basically that's all we are doing. So we are listing the files in this directory, and we will make sure that it is a file and not a folder from that directory. So, and local file system will be a global variable which we will define as well. That looks good. So once we have the file, we can loop through the files and upload the files to S3. And S3 client will be created above, but it's basically a Boto3 library that is used to upload files to S3 in our case. So let's go ahead and just do this. Sorry about that. So what we are doing is we are uploading this local file, which is in the local file system, to our S3 bucket. Again, this is a global variable which we will create soon. And the key. So this will be the bucket name, and this will be the path within the bucket, or you can think of it as the folder within the bucket, and F will be the file name. And we will see what key and F really are. So let's go ahead and fill in these functions one at a time. First, let's fill this get num records. So as you can see here, it is a dummy method, and let's say you have 100,000. The idea is you would call an API that would give you the count of number of records that you have to download, and then download these records in chunks. So that's what we are going to do. We are going to download data in chunks. So what is a chunk? You need to define what this chunk size is. Generally, it depends on your API and the amount of data that each API pull is pulling. But for this simple use case, let's say our chunk size is 10,000. So let's go ahead and define this global variable. And let's go ahead and excuse me, write the download data function. We have that here. So you could do this in a concurrent fashion as well, but to keep it simple, we are going to do it serially. So the idea is we take 10,000 data points at one time. So let's see how to do that. So you start with 0, you go to n, which in our case is 100,000, and then you chunk it up into 10,000 data points per time. So you say that, and then we'll write another method called getData that actually hits the API and pulls down the data. Let's say you start at I, and you go to I plus chunk size, and then you get the data and write the data to a local file system. You can call it write to local data, and so we will see more about these functions, but basically we take this data and write to a function which write to a file which is basically I divided by chunk size. So what this will do is it will generate file names of 0, 1, 2, 3, etc. Right? Let me show you where it is. Like file names like these, and within those files you will have data for IDs from 0 to 10,000 and 10,000 to 20 and so on till 90,000 to 100,000. So we'll see how that corresponds to that range in this GetData function. Let's go ahead and write GetData. So GetData is basically the function that pulls data from the API. So it will have a start ID, an end ID, and a get path. So if you look at this, you can see we create a HTTP connection, and then we make a request, and then we parse out some single quotes to double quotes so that we can load it into a JSON type. And that's all it does. So let's just copy paste that instead of having to. This start user ID, end user ID goes back to this idea of pagination, where you're pulling in chunks. What this means in this context is you pull data while making sure that your data starts at this ID and ends at this ID. So let's say you have 100,000 user IDs. If you give start ID 10 and end ID 100, it will pull the data with those IDs from 0, so from 10 to 100, so 10, 11, 12 up until 100. That's the idea that we are trying to replicate here. So once we get the data, we have to write to local. Write to local is pretty straightforward. You have the data, you write it to a local file system as a single file at a single line at a time, and basically the downloaded data is going to be of this format, like a JSON. So we are just converting that JSON to a string in this parse data function. So open a file, and for each JSON in this data object, write a line to this file. That's all it does. So let's copy that, paste that over here. We still have to paste these functions, so let's go ahead and do that. These are all your standard libraries, like Boto3 for connection to S3, datetime, we will see why it's required, JSON to pass the JSON data, list directory to list the directory structure, and checking if it's a file, and joining paths, and URL lib we use to make API calls. S3 client is Boto's S3 client used to connect and talk to your S3 data store. Local file system. This is a little bit interesting because temp is a local file system that is available when you're running your Lambda function. And the maximum memory is dictated by your Lambda function settings. An S3 bucket, you will have to set your own bucket here, and in the next section we will see how you can spin up your own buckets using a script. Chunk size, we went through this, it's just the size of data you want to pull each time. So this get key is a little bit interesting. So let's see what we're doing here. We are getting the datetime, the current datetime in UTC format, and getting the date, year, month, day, then /r/minute. So what this will do is, since we are running this Lambda function every minute, this will generate a different file path for each run. That is the whole purpose of this get key. So you can see here that we are using this get key and uploading files there. Let's just go ahead and copy paste that. And again, just to restate, we have all these in my blog. I'll post a link in the description below. Let's go ahead and remove this. Paste this here. That should be good. So let's see that we have the function within your data pull directory. All right. So now this script basically packages your code creates a bucket that you specify and grants your Lambda function appropriate um, access to access that bucket. And also it creates something called a cloud formation event, which tells your Lambda function to be executed every 5 minutes. You can go through this code in my blog, but it's pretty standard, straightforward code. Sorry, I shouldn't say standard because people generally use Terraform or something like that to set up infrastructure. But for this simple example, this should be fine. So let's try that. So we have to do chmod 755 to grant permission for it to run. Let's go ahead and run it. So I'm going to create a bucket called start data engineering bucket S3. But remember, here we have SDA bucket S3, but in our Python script, we did not fill that out. So let's go ahead and fill that out right here. So we have to fill that out. Oops. I accidentally deleted it. Let me just go remove that. What do we want to call it? SD bucket S3. Let's call that SD bucket S3 for now. Let's do SD bucket S3. So it's creating some local configuration files required for AWS CLI, creating your bucket, creating policy and roles, which is to grant permissions to your Lambda. And attaching policy to role, it's not synchronous, so you have to wait for a few seconds. Then creates Lambda function, creates a CloudWatch rule to schedule this Lambda function every 5 minutes, and setting the appropriate rule to the Lambda function. So that should be ready to go. Let's give it a few minutes, and in the meantime, let's go take a look at the UI. All right, so once you log into your AWS console, go to CloudWatch. Basically, you can use CloudWatch to monitor your services. So you go to CloudWatch, you go to rules, which would have automatically been created using your setup script. Click on My Schedule rule, and then click on View Metrics. You would see something like this. Basically, it'll show a triggered rule every 5 minutes. And with time, you can see if you let it go for many minutes over, intervals of 5 minutes, you will see this graph grow. But currently, it has only run one time. A better way or an easier way to test this would be to just run a ls on your bucket with recursive on. What it'll do is it'll show you how the namespace works. So you can see like the day is 13. This is in UTC. This is in my local time, which is New York time. So just be aware of that. So you can see like the day is 13, the hour is 0 because it's 12, and minute is 46, and you have like these chunked files 0 through 9. And similarly, 5 minutes later, you have minute 51 and chunked files 0 through 9. So that's how your files get uploaded to S3. So now that you have executed your code in Lambda and it's working fine and your files are getting uploaded, you could download these files and check the content. Seems to be working normally because it's just the dummy data. They're all the same. Now it's time to tear down the infrastructure. So you could use this script. Basically, it just deletes everything you created. Let's go ahead and do that. Let's call it tear down shell file. All right, so let's give it permissions to execute and make sure you're using your bucket name. I'm gonna delete that. So it removes the rule, the monitoring, and deletes the bucket, deletes your Lambda function as well. So that's pretty much the code. Let's look at some pros and cons of Lambda function or serverless in general. So pros, they're extremely cheap. They're only charged at 100 millisecond intervals. So it actually really depends on how efficient your code is. And also there's no server maintenance, security patching, etc. It's super straightforward to test out, and you can use these functions to kind of test out an API that your company is thinking of purchasing. You can set up scheduling and monitoring and alerting using CloudWatch. You can set up alerts to be sent to like a Slack message or via email, whatever you want there. But it also comes with some cons. Currently, the maximum amount of time that a script can run is 15 minutes. So if your data pull is going to take longer than that, it would probably be wise to use some sort of data pull orchestration tool like Airflow or DBT or something that supports what you're trying to do. And it is also space bound. The maximum available memory is you can set is around 3 GB. So be aware of that as well. And the final thing is more design. You can get around this, but basically the idea is if you're having a data pipeline, chances are you might have to change some logic and then start backfilling for historical values. In such cases, using Lambda will require that you handle those backfills or those functionality that allow for backfills, and or might require manual intervention. So in those cases, if you use an ETL orchestration tool, they have these backfill capabilities inbuilt, so it might be easier. So that's it for this video. I hope it gives you a good understanding of what serverless is, how we can easily use AWS Lambda to pull some data to S3, and yeah, I hope it was helpful. If you learned something or if you really like this video, please consider subscribing and like and share and all the YouTube stuff. It really helps out with the YouTube algorithm and get this out to more people. And as always, if you have any comments or questions, please leave them in the comment section below. Also check out my blog in the description below. And have a great time, and thanks for listening.